All right, so let's do the same thing for question number 2. I'm going to create a table of values, and same thing, I'm just going to go from -3 to +3. And if y equals the absolute value of x, my first expression is going to be, my first value that I'm going to plug in is -3. So I'm going to take the absolute value of -3, which is +3. To find the next one, I would take the absolute value of -2, which is +2. To find the next one, I would take the absolute value of -1, which is +1. Here I would take the absolute value of 0, which is 0. Here I take the absolute value of +1, which is 1. And then the absolute value of 2 is 2, and the absolute value of 3 is 3. So when I graph this out, it's going to look a little bit different. Right here, I'm going to go to -3, 3, and I'm going to put a dot right there, okay? Then I'm going to go to -2, 2, and I'll also put a dot. Draw out all your coordinates. If you notice your absolute value graph, if you remember we discussed this a little bit at the beginning of the school year, it's going to look like a V, okay? But here's the thing you need to understand. When you take the absolute value of a number, if the number is negative, it becomes positive. It's the distance away from 0. So right here, we're marking a distance away from 0, and it's always going to be a positive distance. So in this example, and when you have your parent function, it's never going to go below 0. Also, this half of your graph right here is a reflection over the x-axis of this half of the graph y equals x. And that will be true no matter what. So if, for example, if you have y equals 2x right here, then the absolute value of if you have y equals the absolute value of 2x, then it will also be reflected over the x-axis for negative values of x. All right?